Hi, folks. This is the follow-up to our presentation in the lab yesterday, and I solved this problem for you, which is a block uh, with a central hole, and it's subjected to an axial load on both direction of a 2,000 pound magnitude. Now, I told you that this problem can be done based on symmetry consideration. In other words, first of all, in the class, I demonstrated if I apply a force at the end, then you get these unreasonable non-physical stresses at the corners of these rectangles on the sides. And obviously, those are not physical stresses. So if you're gonna, you really have to discard those, ignore those if you're interested in looking at the stress distribution around the hole. That being the case, there is a way to fix it, and one is to create a group of elements around the hole and then just display, for example, later on the stresses in that group. It can be done, but I didn't tell you how to do it in the class yesterday. The alternative is to convert this force into pressure by taking the force and dividing it by the area of this section, which comes out to be, when you do that, 120 psi and apply that. When you do that, this non-physical bulgings of the ends will go away. However, on the test, you do what you're asked to do. If you're asked to apply 2,000 pound, you apply 2,000 pound. Don't convert it to pressure. Uh, now, let me assume that the dimension of the hole is diameter is 1 inch. And notice that there are four scenarios. One is to take, because of the symmetry, but take 1/8 of the model. And this I did in class for you. Okay. And then I said, okay, what if we decide instead of taking 1/8 of the model, just take 1/4 of the model, which is over here. I did this in class also. What I'm going to do today is repeat those. However, I will also do the case where 1/2 of the structure is taken because of symmetry, because the top and the bottom look exactly the same. And finally, which is the more difficult one, is to do the entire block without actually applying any uh, symmetry consideration. Okay, so that's what I'm going to do today. The other thing is that in the class I mentioned that I'm going to do this thing in a way that if you're a pro in Catia FEA, you might say this is unnecessary. I realize that. However, I'm going to do it systematically by using the propagate directory functionality by taking every problem, put it in a folder, and then say propagate directory so that everything is maintained in that one folder that I can look at later and mark it if necessary. All right, so let's go ahead and do that. The first thing I'm going to do is to make the full model, which is going to be 2 by 4 by 10. All right, so let's go ahead here and we start Catia. The version of Catia that I'm using is 20 R56 2023, and this is what we have at university. Okay, so that's fine. Now, let me make the model. So on that vertical plane, I will sketch a centered rectangle like so. Okay, let me dimension these things. This one is 10. So without any symmetry, this is 10. And this side is 4. Okay. And then I will make a centered circle here for that hole. And the diameter of it is 1. Diameter is 1. There we are. Exit. And I will pad it in each direction by 1 inch. The reason I do it symmetrically is because later on I want to use cuts in order to cut this thing and get the symmetry into consideration. So let me make this thing 1 and then we say okay. Now we're going to apply material to this. So the apply material icon, if I can find it right there on that part, I'm going to use steel, but specifically I've said I want to a very specific Young's modulus. So if you click on the steel branch here, select the analysis tab. I'm going to change this thing to uh, 3 e to the 7, 30 million psi, and Poisson ratio 0.3. Now, notice that if I was asking you to do default material properties for steel, then it's okay. You don't have to make that change. But here, specifically, I said uh, these are the numbers that I want. Now, what I'm going to do is I'm going to save this model. So let's do it like this. File, save management, save as. On my desktop, I make a folder, and the name of the folder will be the block with central hole. Okay. And then say okay, and then open. And say fine. Now, if you go to my desktop, you'll see that I have a folder called block with central hole, and this original model is sitting there. When I do my 4 cases, I will make 4 folders. I'm not going to touch this part 1. I'm going to make 4 folders with each one using the appropriate number of planes of symmetry. So let's go back here. Now, first thing I'm going to do is I'm going to take a quarter model or 1/8 of the model. So what I can do is use the split to cut it like this, split to cut it like that, and split to cut it halfway. So this is 1/8 of the model. Okay. Now, this is pretty much done. So now I'm going to go to Start, Analysis and Simulation, Generative Structure Analysis. It's a static analysis that we're doing. I don't like this particular rendering. I'm going to change it to non-material shading. Now, let's apply our restraint. So we have a surface slider right here, restraint surface slider. This is a plane of symmetry. The back is a plane of symmetry. This is a plane of symmetry, and the bottom is a plane of symmetry. Okay? And I said that I'm going to apply a pressure on that face of a magnitude 125 psi. Except that if I put a positive number, it's going to actually compress it. So if you want a negative number, you put a minus there, and you say, okay. All right? Now, what I can do is do the saving right now. I haven't run it, but I can do saving right now in the right folder. So let me go ahead and say File, Save Management, take the analysis, not the other guy, take the analysis, save as, in that same folder which I called block with a central hole. See if I can find it. Block. Block with a central hole. Where is it? If I can find this thing. Is that what I called it? Let's see. I can't remember. What did I call that thing? Oh, right here. The block with the central hole. I'm going to make a new folder. And this is 1/8 model. 1/8. 1/8 model. Select it. Say OK. Say OK. Make sure you say save. Propagate directly. Make sure you say propagate directly. Say OK. Notice that both of these, this part, as I modified it, goes into 1/8 model, and the same thing with the analysis, and then say okay. Good. Let's actually go check it. If I go to my desktop, there is a folder created in that original block with central hole. Double click on it. I have the part, which is 1/8 of the model, and I have the analysis, which I'm going to run right now. Okay, so let me go up here so you can see what happened. And this is not resaved. Okay, and just run it. Don't worry about this warning. Look at the stress distribution, change the rendering to material shading, and there we are. And the number that you get is 362 psi based on the size of the element that I've used and the geometry. Okay? Now, and make sure you click on the floppy so that everything is saved in that folder. Okay? The analysis. Now, I'm going to close this. And I'm going to close this. If I go back here, if I go to my folder, check the stuff that's in 1/8 model. Part 1/8. Analysis for 1/8. However, if you go to this thing outside of that folder, this should be the full model. Right there. Okay, now we want to do a quarter model. Okay, so we're going to go and split, split with that plane, and split with the horizontal plane. Now this is 1/4 of the model. Okay, so if I go to, for example, generative structure analysis, change the rendering here. We're doing static. Yeah. The pressure is right there, no problem. The surface slider is at the bottom, and it's at this side, no longer on the back side and or the front side. Now, if I can save this thing right now. So you go to File, Save Management, take the analysis, Save As. Don't do it in this folder. Go make a new folder, 1/4. 1/4 model. Say okay. 1/4 model. Say open. Okay. Save. Do not forget to do save propagate directory. And when you do that, it's going to go, everything is going to go into that 1/4 model. The part is going to go there, the part as I modified it, and the analysis that I haven't run yet is going to go there. Say okay. Now, then I'm going to run, and it's going to bomb out. Run. Say okay. It's going to bomb out. It says I can run because I talked about in class is that this thing is allowed to move. It's a rigid body in the x direction. If you didn't recognize that, although it didn't run, you can plot the deformation and then animate it to see what happens. So it can move as a rigid body in the x direction. So we say fine. Now let's me deactivate this. Good, you're back here. To prevent that rigid body motion, what I said is that go to the restraint, using this thing called user-defined restraint, select this corner point or any other corner point as a matter of fact, and say, hey, you can move in the X direction. You can move in the X direction. Say okay, and now run it. This time it will run, you will not get an error message. However, when you try to look at the deformation and animate it, nothing seems to be moving. The reason is that the scale was set to a very low number. See that? You go to analysis tool right here, analysis tool, you click on it and say, give me default factor, default, and now you can animate it. Or you can plot the von Mises stress if you want. There we are. Change the material shading. Again, roughly 380. Same thing. Good. And now click on the floppy so that everything is saved in that last folder. I did this problem and the one prior to that in the lab. So the next two things that I'm going to do was not done in the lab. And I promised that I was going to make the video and post it. Now, let's check. Click on this, click on that, close everything. Let's make sure everything is there. First of all, this guy must be the original model. Full model. Good, good. Let's go to the 1/8 model, the one that I ran initially. If I double click on the analysis, I get the 1/8 model. There. It was not lost. I did not override it. If I go to the one that I just did, 1/4 model, analysis, you get 1/4 of the model. So, okay. Now, let's go do the rest of the problem. Go back here. Go to the part. That's not changed, the original one. Okay, good. Now let's do a half. How do I do a half? I'm going to split this thing only with this plane. There we are. This is half of the model. Okay. So immediately, I go to the analysis and simulation, generative structure analysis, static analysis, change this thing to non-material shading. Okay, let's apply pressure. Pressure on that face and on this face, and say okay. Now, surface slider, only at the these two bottom faces. And say okay. And you can save it now, or you can run it and save it. It's entirely up to you, but I'm going to do that now. So you go to File, Save Management, Analysis, Save As. In that folder, I create a new folder called Half Model. Half a model. And this is going to go into that half a model. Do not forget to say propagate directory. Okay? Do not forget to say that. Everything is going to go into half model. The part that I made and the analysis. Say okay. Now, if I run this thing, it's going to bomb out. You'll see why. If I run this thing, there we are. Say okay. And then we're going to say, all right, you didn't run, but can you show me why? If you click on the deformation and animate it, you can see that this thing can because the bottom is surface slider, nothing is restraining it from moving like that. So I have to prevent that rigid body motion. So let me say, okay, deactivate this plot. All right. So now I'm going to say, hey, you cannot go, for example, in the X direction, just like before. Click this, select this bottom point, and say, you cannot go in the X direction. Now, if I run it, it still bombs out. You'll see why. It still can bomb out. So let's say, let's check it out. Run it, wait for it to bomb out. Because there's something else you have to do. If you plot it, you can see that still. Let me change. You can see that this point is fixed. This point cannot go like that. It's fixed. However, this thing can still, because there's a slider at the bottom, can slide on that. So you say, fine, have to do something else. Now I'm going to say, hey, you cannot go, for example, in the, now here you have to think a little bit. Say this point cannot go, for example, in definitely in the X direction, okay, and in the Y the Y direction, or you can do So let's go ahead and do that. This point, and if it doesn't work, we're going to fix it. This point, for example, cannot go in the X direction. That takes away the rigid body motion, and it cannot go in the Y direction, direction 2. Okay. Let's run it. Hopefully we don't get that error message. It didn't. Let me reset. Let me change my, let me plot the deformation and reset the thingy. And Mm. Yeah, okay. So we can animate this. And that takes care of it, right? That takes care of it. So let me stop this. If you don't believe it, let's plot the stress, change this thing to material shading. Yeah, very close to what we had before. No problem. Now make sure you click on the floppy so that this result is saved. Okay, let's check. I'm going to close that. I'm going to close this. We're going to inspect. Half a model is the one that we just did. This is what we have. If we go back to the 1/8 of the model, it's there. This is 1/8 of the model. And if we go back to the 1/4 of model, it's there. And finally, if you go here and check our part, this is the full model. All right. Now I want to do this problem, okay, without any planes of symmetry. So here's what I'm going to do. Go to generative structure analysis. Say, okay, let me change the rendering here. All right. And pressure on this face and on that face and nothing else, right? No planes of symmetry. There are no slider surfaces or anything. So let's run it and make it, watch it bomb out. Sure. Can I see how it deformed? Ooh, this is completely free to rotate and move as a rigid body in space. So how do I fix this thing? Okay, cancel that. Deactivate this plot. Look, first of all, one point, for example, this corner point, I say, hey, you cannot go, let's say, you cannot go anywhere in any direction. So that point is kind of fixed. Okay. If I run it, it's going to bomb out because this will kind of rotate about this point. Now we're going to say, okay, another point such as this cannot move to take away spinning about the x-axis. I'm going to say cannot move up or cannot go to the right. So the x direction I release. So the x direction I release. Now notice that the way it's going to work here is this whole thing can pivot about that line. Okay, keep pivot about that line. Don't, but it allows it to shrink this way too, because if this is loaded, this whole thing will shrink. Say, okay, if I run it, it will bomb out. Let's try it. Let's try it. It will bomb out because it can spin about that axis. You can see that. If you look at the deformation, see that? It can spin about this axis. The final thing is that, okay, no problem. So what I'm going to do, I'm going to take away that spinning. So I take one point here and say, hey, you can't go up or down. So, what I have to do is you have to be careful so that you don't over constrain it. Let's see now. To take away that going up or down, we have to be very careful because you might say that can I pick anything that I want? The answer is no. So let me take this point. Hey, say you can't go up and down. See what happens. So that point, you cannot go up or down. So translation 3 and uh, let's run it and pray. Yep, it worked. So look at the deformation, change the scale to default, and you can animate it. Oh yeah, it looks good. But look at the Warmisa stress, and change this into material shading. Oops, material shading. exactly the way the other two behaved, and the numbers are very close. Now, do not forget to save this thing. So File, save Management, take the analysis, save as, take the analysis, save as, and make a folder here. We say full model, okay? Full model, save, propagate directory, and then we say okay. So what happens if you close these, you go back here, you have all of these model saved in an intact way, and this one is never changed. This one is just the full model, no problem. And for example, if you go to the, just hypothetically, you go to the full model, analysis, there you are. If you go to the quarter model, analysis, there we are. There is no danger of losing any of this stuff. Now, let me go to that full model. Let me go to that full model. There's something I want to show you. Full model, analysis. Now, notice what I did with this problem to fix this issue. I'm going to deactivate this. I'm going to deactivate that. Change the rendering so that you can see it. You can see it better. Right there. Now, notice that there is a point here which cannot move in a certain direction. There is another point here that cannot move in two directions. And there is a third point that cannot move in direction 1, 2, and 3. This is called the 1, 2, 3 rule, which is commonly referred to in FEA as the 1, 2, 3 rule. To take away rigid margin motion completely, I'm using the 1, 2, 3 rule. There is something that I'm not going to tell you, and I haven't talked about it in class. There is a way to apply this automatically. Apply 1, 2, 3 rule automatically if you're interested to see me. No, if you're interested to know, see me in class or ask me about it. Okay? There is a way to avoid this 1, 2, 3 rule by, there's an icon here, which I'm not going to tell you right now unless you're interested, and it will take that into consideration. Let me remind you that there are other stuff here. Okay? All right, folks, good luck.